Hi, Victor Morganti here from FactEngine. We're going to dynamically load a model into Boston along with its metadata lineage information and have a look at doing knowledge extraction inside the Boston conceptual modeling software at the same time. We've got Boston open in front of us and a brand new empty model in the Model Explorer. It's got just one page which is empty at this stage, and when you right click on the model you can select the FEKL uploader, and FEKL stands for FactEngine Knowledge Language, and I'll explain FactEngine Knowledge Language in a second. So we've opened the form and there's a series of tabs. We just want the first tab for this demonstration. We're going to upload the conceptual model or part of a conceptual model from a JSON file in FactEngine Knowledge Language. So I'm just going to open that JSON file, and that loads up into a grid. Now these set of statements in the first column are FactEngine Knowledge Language statements. Now FactEngine Knowledge Language is a controlled natural language for conceptual modeling, which has a morphism to object role modeling, so that you can directly construct object role models inside Boston using FactEngine Knowledge Language. It's the same language that's used in Boston's Virtual Analyst. If you want to find out more about FactEngine Knowledge Language, just do a Google search on FactEngine Knowledge Language and follow the links. You'll be taken eventually to a page that gives you the documentation on FactEngine Knowledge Language, or you can just go to the documentation menu at factengine.ai and click on FactEngine Knowledge Language, the section. And to give you a brief overview of FactEngine Knowledge Language, you can dynamically create your model using controlled natural language, such as company is an entity type, defines an entity type. Or if you want to define an entity type in its reference mode, so the way it's identified, you'd say company is identified by its ID. And if you automatically wanted to set a data type for the ID, you'd say company is identified by its ID, written as auto counter. I'll give you another example and see if I can make that a bit larger. Company name is a value type, or we can say company name is a value type written as string fixed length 100. And here's another example. Name is written as text fixed length 100. So all three of those statements will create a value type in an object role model inside the Boston conceptual modeling software. So these FEKL statements have been extracted from a document. So you can engage with your implementation partner to do knowledge extraction from your corpus of documents to create FEKL statements so that you can create the model inside Boston. At the same time, you can capture metadata lineage information. So I've handmade this particular JSON file, this particular upload, but the primary information for this FEKL upload is from a document ECSS EST7041C, which is a document kindly shared with us by ESA, and that document is a document by the European Corporation for Space Standardization. So its title up the top here is ECSS EST7041C. So you can imagine where you could use artificial intelligence or SPACY or core NLP to extract fact types and entity types and value types out of the documentation dynamically, and capture at the same time metadata lineage data like the the page number, the section ID, the section name, even the line number, etc. for storing within Boston. So if we go back to Boston, I've got a series of FEKL statements. We've got the document name, its document location, so where it's stored, the location of the JSON file, whether or not it's an object type, the page number, the line number, the section ID, the section name. If there's a unique requirement that you can dynamically gather from your documentation when you do your knowledge extraction, the requirement ID, and even start offset and end offset within the page when it's converted to text. This in error is filled in when we load the file. Now within Boston we can set defaults, so we can set a default location name, document name, location, section ID, section name and page number. And the reason why we would do that is if you're running Boston inside a web browser, so you're doing collaborative modeling over the internet, you can set the document location to a location that is accessible from the server that's serving Boston. So you can have defaults if you're doing page by page loading of FEKL statements to create your model. So let's start processing. So click on Start Processing. That's stepping through now, and you can see that it's dynamically creating pages. So there's FEKL statements to create pages in your document, and you might dynamically say, well, this is an interesting topic, it deserves a page within the model, so we'll create a page. So there's only a few lines in this file. Now this has been tested up to 3,600 FEKL statements, so you can certainly load a very large model into Boston using the FEKL uploader. This line here is orange because it had an error. If I click on the error, I can see that it's got a syntax error. That shouldn't be CNCPT, it should be concept, and we can change that and reload the file. You can export the errors, so if you wanted to export your errors, fix them and re-upload those, you can do that. And you can run the same file twice. It won't create duplicates, and it won't create duplicates of the lineage data either. And you can hide those that have been processed. It says these others in grey here haven't been processed because they're duplicates, so it's not going to create satellite company twice, for instance. It'll only do that once. So now that we've loaded the model into Boston, we can go to the glossary view, and we've dynamically created these model elements within the model. If I pick on one of those, say subservice type, sorry, you can see it's what's been captured for that. There hasn't been too much captured other than that it's an entity type at this stage. And view its lineage data. So this is the lineage data that's been captured. So the document name, where it's located, where the JSON file is located, the page number, the line number, the section ID, the section name, and its unique requirement. You can have multiple lineage items per model element down to the column level, say on the entity relationship diagram view. And if Boston has access to the document, you can open the document and it'll go to that page number in that section and highlight the term that you've been looking at. So it's highlighted subservice type, and there's all this information about subservice type. We didn't capture much information on subservice types, so what we're going to do is we're going to get the page as text. We're going to go back to the FEKL uploader, and we're going to go to the knowledge extraction tools. So right click on the model and select knowledge extraction tools, and paste that into the document text. And we can do such things as extracting fact types, readings and object types using statistical methods, core NLP, or we can use artificial intelligence extraction using at this stage GPT-4 or the various chat options for OpenAI. That option is only available if you have permissions to set the API key for your large language model for security purposes. If you're working in a corporate environment and where Boston is being served over an intranet or extranet or the internet, you might not want people using a large language model for security purposes to extract knowledge. We're using OpenAI's 30-day retention models where data is deleted after 30 days and is not used for training. So we're not going to do that for this demonstration. We're just going to use core NLP. So let's go ahead and use core NLP to extract knowledge from that page. So that's gone through the document and extracted keywords and fact type readings for fact types in the object role model. We can see the items that we already have are highlighted blue. If I refresh the page, we can see that whatever's already in the model is captured as in various colors. So blue for entity types, green for value types. We can add directly any items to the model that we want to directly from inside the knowledge extraction tool. So we'll say observable is a entity type, for instance, and that's created an entity type. There it is in the verbalization view, and if I refresh there, if observable was in here to be coloured blue. We might say function is a entity type. We're going to say subservice is an entity type, for instance, and that's directly captured in the glossary and inside the model. So subservice, observable, they're already in the glossary now. So with these fact types, let's just prune out a few here that working as an expert I can identify aren't really fact types that I want to capture. So where the heuristics has come back with something that obviously isn't going to be a valid fact type for us. So we'll just prune out a few there. So when you're using knowledge extraction and the FEKL uploader in Boston, the idea is that these are all going to be object types. So all of those are fact types. The idea is to get one or more experts to review the knowledge that's been extracted as it's being loaded into the model, so that you can formulate a conceptual model that's been vetted by an expert who's familiar with the documentation and the universal discourse. So I'm just going to copy all those fact types and go back to the FEKL uploader, and rather than JSON now, we're just going to put all of those suggested fact types as text into the text-based FEKL uploader and process those. So I've got a duplicate there, I'll get rid of that, and I'm going to upload those. So I'm not pretending to be an expert here, so we'll just take what's been extracted verbatim at this stage, and now you'll see that the glossary has more items in it, and we didn't set any defaults so they won't have any lineage, but we could have put the page, the document name, the location, the section ID, the section name and the page number there, and they would be reflected in the data lineage captured for those items. Now if I want to say have a look at mission, and we can see that mission has a service type, I can view it in the model dictionary, so I should have mission there. If I refresh that, there's mission, and if I want to, I can create a page for mission. So that's created a page in the model for mission. I'll just drag that to the middle of the page, and then I'll add the related fact types and do an auto layout. And we can see that mission has a service type, and so we'll put a uniqueness constraint over the role joined to service type, and of course we can give mission a reference mode, so it's unique identifier, and we'll do the same for service type. And we've got a valid object role model. So your experts will go through the knowledge that's been extracted and complete the conceptual model. So we've looked at loading a JSON file with fact engine knowledge language statements with the data lineage data, which are loaded into the model to create your conceptual model. You can view those in the glossary and dynamically view the object role model for that particular item. So if I just click on mission now, we can see that a mission has one or more service types, and there's the semantic verbalizations for mission. So mission possibly has more than one service type. Each mission has one mission ID, for example, and it's an entity type in our model. We've seen that we can capture metadata lineage information as extracted by whatever source you or method you use to do knowledge extraction from your corpus. We can view the documents directly inside Boston if they're accessible by Boston, and navigate around the model. We can copy information from the model to the knowledge extraction tool and use statistical methods, core NLP or artificial intelligence extraction using large language models and prompts to extract knowledge, and we can tidy up the model using the standard methods in Boston for conceptual modeling. So thank you very much for watching. I hope you enjoyed the video. Please hit like and subscribe if you like the video, and I'll see you in the next video. See you. Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from Fact Engine. Fact Engine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, Fact Engine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.